Hello everyone. For today's video we're going to be taking a look at how we're going to calculate the area of a parallelogram. So let's jump right in, and we're actually going to skip down here and we're going to take a look at what the formula is for the area of a parallelogram. It's actually really easy. The area of a parallelogram is just the base times the height. That's it. Base times height. But the question is, what do we mean when we say the base of a parallelogram, and what do we mean when we say the height of a parallelogram? And so for that, we're going to jump right up here and take a look at a couple definitions. So first of all, each pair of parallel sides of a parallelogram are called the bases of the parallelogram. So a parallelogram, since a parallelogram has two pairs of parallel sides, that means it technically has two pairs of bases. When you're using the formula for the area of a parallelogram, you just pick one of the pairs of parallel sides and you call that your base. So in this diagram right here, I'm going to call this side and this side my base. So this measurement from here to here would be my base measurement, which of course should be the same as this measurement because we know that the opposite sides of a parallelogram are always going to be congruent. So these two measurements should actually be the same. We're only going to use one of them. The second definition that we need to know is this one. It says the perpendicular distance between the bases of a parallelogram is called the height of the parallelogram. So if I look at my diagram right down here, the height of my parallelogram would not be this side. That's the mistake a lot of people are going to make on a parallelogram. They're going to say, okay, well this side is the base, and that means this side down here along this side, that must be the height. And it's not, because we're going to measure the height in a way that's perpendicular. The height is going to be the perpendicular distance between the two bases. So this dotted line right here, which is actually drawn inside my parallelogram, that could be my height. It's the distance from the top base to the bottom base in the way I was looking at this parallelogram. Sometimes, however, you're also going to see that height drawn outside the parallelogram, like this dotted line right here. It's still going from the top base down to where the bottom base is, so that could be considered our height as well. We just don't want to use the other side of the parallelogram as our height. Now, if you remember back to the 8.4 video, I gave you a little note that might help you remember this relationship between the base and the height in the parallelogram. I said to remember that the height is always perpendicular to the base. And you can see that happening here again. Our height is perpendicular to our base. So it's true about triangles, and it's also true about parallelograms. And as we're going to see in the next video or two, it's also going to be true about trapezoids when we start looking at calculating the area of a trapezoid. So area of a parallelogram is just base times height. Now let's apply that formula in a couple different scenarios. In this example, we actually are not trying to find the area of the parallelogram. We have the area of the parallelogram. What we want to know is what is the height of the parallelogram. So you can see in our diagram, we're given the area as 264 square feet. We're given this measurement as 11 feet, and of course, since that's a side length of my parallelogram, that means that's a base right there. And then this would be the height then, because it's measuring from the top down to the bottom in a way that's perpendicular, in a segment that's perpendicular to both the top and the bottom. So this 2x plus 4, that's our height. But we don't want to say that the answer is 2x plus 4. We want to find the value of x and then figure out what number would this be. So what we're going to do is we're going to start off by writing our formula. Area equals base times height. And then we're going to fill in, there's three unknowns here, we're going to fill in the two that we have, and we're going to use this expression for the height. So we're going to say that 264, we're just dropping that in for where the area is equal to 11, we're just dropping that 11 in for the base, times what we have in the picture for the height, which is 2x plus 4. Now you can see here we have an equation that you should be able to solve. This is an Algebra 1 style equation. The way I'm going to do this is I'm going to go ahead and I'm going to distribute this 11 into this parentheses. So I'm going to have 264 equals 11 times 2x, which will give me 22x, plus 11 times 4, which will give me 44. Now I know I need to subtract the 44 from both sides. So now I have 220 equals 22x. And then I'm going to divide both sides by my 22. And that tells me that 10 is the value of x. But I'm not done with this problem because I still haven't found the actual height. I haven't found this measurement. I just found what x is equal to. I know that the height was 2x plus 4. So I'll take my 10 and I'll put it where the x is. 2 times 10 plus 4 is my height. That's 20 plus 4, or 24, and since I have a unit in this problem, I'll go ahead and tack it onto my answer. 24 feet would be my answer. Not feet squared. Feet squared is for area. You can see we use that unit right there. Measuring the height is just it's just feet. So 24 feet would be my area of this parallelogram. Now in your note sheet you have a couple checkpoint questions to try, so this will be a good point to go ahead and pause the video and try those checkpoint questions. Okay, let's move on. We have one more thing that we're going to talk about here. We're going to look at the length of we're going to look at the area of a rhombus. Now a rhombus is technically a parallelogram, but we can actually find the area of a rhombus in a slightly different way if we want to. We can use the lengths of the diagonals of a rhombus in order to find its area. We can't do that with all parallelograms. It only works for rhombuses. Remember, rhombuses are parallelograms that have 4 sides that are congruent, like I have down here in this picture. And the formula that we can use for a rhombus is area equals 1/2 diagonal 1 times diagonal 2. Or the way I usually write that is A equals 1/2 D1 D2. Diagonal 1 times diagonal 2. So let's look at example 2 where we're going to use this formula. It says in this diagram AC is 22. So let's go ahead and sketch that in. From A across to C is 22 centimeters. And from B to E is 9 centimeters. So from B down here to E is 9. But that also means then from E to D would be 9, because we remember that in all parallelograms the diagonals bisect each other. So if this part of it's 9, so is this part. And that would mean that diagonal BD, from B all the way down here to D, would be an 18, or 18 centimeters. So our lengths of our diagonals, one of our diagonals is 22 centimeters. The other diagonal is 18 centimeters. And it doesn't matter which one we call D1 and which one we call D2. That's just to kind of indicate that we should have 2 separate measurements here for D1 and D2. But we have a 22 and an 18 for those diagonals. So to calculate the area, it's 1/2 of D1 times D2. So we're looking at 1/2 of 22 times 18. And 22 times 18 is 396. Half of 396 would be 198. And our unit would be, let's see, we were using centimeters, and this is an area, right? The area is 198, so our unit gets squared. 198 square centimeters is our area for this rhombus right here. Okay, folks, so now you should know how to find the area of a rhombus using its diagonals, as well as the area of a parallelogram using the base and height measurements. We will see you in the next video.